We're live. You never believe me.
I always require some kind of external kind of confirmation. But I'm going to change my background because
Yeah, that makes sense.
This is last week's background.
I am going to put Discord into Do Not Disturb because my ear just went boink, boink, boink multiple times.
Okay. Boink, boink, boink.
Yeah, I got 3 rapid fire messages that each made a boink all in my ear.
Yeah, I use Discord wrong, which is that I don't. And so people are like, I've been sending you messages on Discord. I'm like, oh.
Yeah,
right,
I use Discord to the point that we now have one set up for the group of us who all live in Edwardsville that we forced our significant others to also join. Yeah. So like the other day, Annie's significant other was making a run to a meat store 2 towns over that happens to have a Dunkin' Donuts. So we were all like on the Dunkin' Donuts bandwagon. The show is not sponsored by Dunkin' Donuts. Mm-hmm. It could be.
It could be. We would be fine with that. Actually, I don't know if we have Dunkin' Donuts in Canada. So
they're really
your money to buy Tim Hortons, which I wouldn't.
They're an East Coast thing, and like so the box like made me have all these flashbacks to growing up and home, and because there's just this distinctive smell of tasty cake donuts and really bad coffee in a box of Dunkin' Donuts. And it's just, it was the smell of home. And my dog is just like, Mom, it's okay.
There are other choices now. Oh, there you go. Someone's saying they thought Tim's owned Dunkin'. Maybe.
I don't know.
Okay. How you feeling? You ready?
I think, let me find where my audio software went. It's open. I just don't know where it is in all my screens. Thought it was open. It used to be open. Apparently it's not open anymore. That is so weird. I'm so confused. Pardon me, everyone, while I have a moment of where's my audio software crisis.
Well, I'll just doom scroll a little while I wait for you.
Yeah, I think we've both been doing that a lot lately. Fraser and I both have connections with the Ukraine. His are a lot more current. Mine are just memories. And a lot of my students have family from that part of the world.
Yeah. Did you find your audio software?
Yeah, and then I clicked something I didn't mean to click, and now I'm trying to get to the right place. So I've come to the conclusion that when a world war starts, everyone should just get 2 weeks off to get their shit together, and that does not actually happen.
No.
Instead, we continue along, pretending everything is all right.
It's the least we can do. The least we can do is not fall apart.
All right. I am ready to press record in all the places. I'm pressing it for the video. I'm pressing it for the audio. It is recording. Hello, okay. Allie. Hello, Rich. Hello, Nancy. Hello, Beth.
All right, here we go. Astronomy Cast, episode 633, Weirdly Habitable Worlds. Welcome to Astronomy Cast, our weekly facts-based journey through the cosmos, where we help you understand not only what we know, but how we know what we know. I'm Fraser, Cain, publisher of Universe Today. With me, as always, is Dr. Pamela Gay, a senior scientist for the Planetary Science Institute and the director of CosmoQuest. Hey, Pamela, how you doing?
I am coming to the conclusion that we should no longer ask that question. And I think I mentioned this in the last show.
Yeah,
we just need to ask, are you okay? And the answer is, yeah, I think I'm okay. Are you okay?
Yeah. I'm okay. Yeah. So then if I say, like, because I can't not ask how you're doing, but you can say, I'm okay.
I'm okay. I can say that. It's true. It's true.
Exactly. All right, well, we've always assumed that habitable planets would need to be like Earth, a terrestrial planet orbiting a sun-like star. But now astronomers have been discovering planets in the habitable zone around very much non-sun-like stars. What strange places could be habitable? And we'll talk about it in a second, but it's time for a break. And we're back. All right, so give us like the textbook definition of a habitable planet.
So
yeah.
The textbook definition is a planet that exists in the region orbiting a star where it gets enough energy that you would expect water at its surface to be liquid if there is sufficient gravity and pressure.
Right.
So Earth, Venus, Mars all have the potential to be habitable to a degree. Mars didn't stay that way. Venus overshot. And this brings us to the Goldilocks phenomena of our own planet Earth.
And so, like, if Venus had a better atmosphere and maybe plate tectonics, it could be, it would have liquid water on its surface. If Mars had a thicker atmosphere, maybe a protective magnetosphere, it would be maybe 5 times the mass. It could have liquid water on its surface. And so obviously there's lots of reasons why you can discount it further, but just as a baseline, just distance from the star creates this zone. And so that is the habitable zone. And obviously, there's all kinds of reasons why things could be uninhabitable from there. But then if that's the textbook definition, what was sort of the assumed planetary system where you would find planets that could be habitable?
I'm going to wait to answer that until the fire trucks finish going by.
All right.
Sounds like they turned the corner. All right. So beyond just the thermodynamics of the issue, which you summed up really nicely, there was also this assumption that you needed to have a sun-like star, something that was long-lived, that gave off a similar spectrum of light, that didn't go through the terrible first few billion years of nasty flares. And so that brought us to the conclusion that you needed to have a sun-like star, you needed to have a terrestrial planet orbiting in the habitable zone that was roughly the right size, spin rotation magnetosphere. And so we started out looking for planets around sun-like stars because that's kind of where we placed the limits. And then, of course, you also have to have the correct composition. So the solar system has to have the stuff to actually make planets.
But it turned out finding planets around sun-like stars was tricky.
Right. So sun-like stars are fairly big. And because they're fairly big, we don't see the wobble as easily with more distant Earth-like planets as we would with a much smaller planet that has a much closer in habitable zone and a much friendlier ratio of sizes.
And I guess the other issue is that because the habitable zone is so far away from the star, any planets that are passing in front of the star do on a very long, slow timescale, like once a year. And so it's going to take you many years to confirm the discovery of a planet in the habitable zone around a sun-like star.
And it was really hoped that Kepler would give us that opportunity. But as happens far, far too often, the reaction wheels just didn't let that be a thing.
Yeah, poor Kepler. Born up for Kepler. Right, and so weirdly, we right now we have still not found a Earth-sized world orbiting within the habitable zone of a sun-like star. But we have found a lot of other planets in the habitable zones of their stars. They're just not very sun-like stars.
No, and every time we think we have placed a limit on this kind of star cannot have planets, unless you're talking about that metallicity constraint again, the composition. Every other restriction we've put in, we've been proven wrong. It turns out planets just planet pretty much everywhere.
All right, we're going to go into some of those examples in a second, but it's time for another break. And we're back. All right, so let's start with red dwarfs.
All right. So the nearest planet to our solar system that is not in our solar system are the planets orbiting Proxima Centauri. This is the nearest star to the planet Earth, and we have found a variety of planets, including a Earth-sized one in the star's habitable zone. And so it turns out these itty-bitty little stars that we didn't think could support planets, because how were they going to hold on to enough mass while they were forming, are actually forming Earth-sized worlds. Now, the thing is, because these are much fainter, much smaller stars, we're looking at, when they have things in their habitable zone, we're looking at like order of 10-day orbital periods. So a year and a day are not going to be anything like what we're used to, but it's the thermodynamics, the temperature regime that defines habitable or not. So life.
So even a red dwarf has a teeny tiny little habitable zone, and we found planets orbiting within this. And I guess the surprise, as you said, was that they are Earth-sized worlds. You would expect teeny tiny planets around teeny tiny stars, but actually we've got Earth-sized worlds around these small stars.
And the most famous of these systems is the TRAPPIST system, where TRAPPIST-1 has a small entourage of planets that are, many of them, potentially habitable, that are, again, sizes that we can imagine finding evolution on of some sort. These are rocky worlds again, just orbiting a itty little tiny star.
What are the downsides of these planets? I mean, they definitely are in the range where they're warm enough to have liquid water on the surface, but being around this red dwarf star comes with a few downsides.
Yes. So the number one downside is if you are on the inside of that habitable zone, the Venus side of the habitable zone for these little star systems, you are also probably tidally locked to your star, like the moon is tidally locked to the Earth. This means one side of your world is always facing the star, and that side gets really, really hot, while the other side, not so much, and you have massive windstorms. Now, there are models out there saying that you can have habitable conditions on these planets for some definitions of life. Building large buildings probably is not going to be a thing.
Right, yeah.
But it's possible.
I mean, I talked to a scientist about this, and there's sort of this misnomer that the front side would be completely baked and the back side would be frozen solid, and that the only place that you could live would be on this thin little ring. But the reality is that the whole front side would be warm, but because of those winds, as you mentioned, it's circulating that cold air and regulating the temperature. And think of it more like a jungle, that the whole front side would be quite hot, but not boiling water hot. And so in theory, one whole hemisphere of the planet would be habitable at the same time, and there would be no day-night cycle. It would just be always day, or always night, but nobody lives where it's always night, so it's always day.
Well, and even creepier than that, the sun always stays in the same place in the sky. And
Yeah.
so as you move around the planet, you see the star moving through your sky. And it's not just that north-south adjustment we can see if we go on a road trip from, say, Florida to Toronto. It is, you can actually road trip to sunset. And
Yeah.
that's just a fascinating idea.
Yeah. And the stars themselves are a little temperamental, a lot temperamental.
When they're young, they do go through a terrible 2 billion years or so. Early on red dwarf stars, as they're settling into their fully convective beings, these are stars where the entire atmosphere of the star is circulating like a lava lamp. The fuel from the outer layers of the star is getting brought into the core, and it's just cycling. And early on, while it's settling into figuring out how to be a stable star, there are some X-ray outbursts which have the ability to do bad things to early worlds. And so the question becomes, we know that in our solar system there was a much shorter period of badness that occurred. And afterwards, water was somehow brought into the inner solar system again. Planets were able to settle out and evolve into what we see now after those first couple billion years that included the Great Heavy Bombardment. Well, what happens in a solar system where maybe not your biggest enemy is the rocks falling out of the sky, but the sun flaring at you, and that the sun keeps flaring at you through the end of that period of bombardment? Can you still develop an atmosphere? Can you still get your water back? These are questions we don't know.
And it's important to understand this. Like, these flares can be hundreds of thousands of times more powerful than anything that the sun puts out. You're close to your star because that's where it's warm enough, and so you're just getting hit by these shotgun blasts of radiation and stellar material that will strip your atmosphere away, blast away your ozone layer, radiate the surface. So it does sound like a rough period.
Yeah.
But who knows?
Yeah.
Like who knows if the magnetosphere gets locked in early enough, then maybe you can be protected. Maybe life can get going on the shaded part of the planet and then move back over to the front side of the planet once the star has settled down. So they're pretty fascinating. All right, let's go to the other end of the spectrum. Let's look at giant stars vastly bigger than the sun.
And this is where I kind of am in love with the Centauri system, Alpha Centauri, Proxima Centauri, that entire system, because Alpha Centauri b is a giant star. It's in a binary system, and there is a planet that is, they're still trying to figure out a lot of details about it, but it is out there orbiting these two stars, showing that pretty much anything is possible. And these things start to get referred to as super habitable planets because they're orbiting binary stars and we shouldn't be allowed to name things.
So sorry, I need to sort of fact check you on this.
Okay, did I read a bad article?
You said Alpha Centauri b. Yeah, there's
Yeah.
no planets at Alpha Centauri.
Then what the heck is this picture?
There are unconfirmed planets, and also you said that Alpha Centauri b is a super giant, but it's not. It's about the mass and size of the Earth, of the sun.
Okay, hold on.
So you're sort of shifting into a binary. So let's hold on. Like, there are some other, like, there's this newly discovered binary star, this Tatooine. So why don't we talk about that one?
Okay, and I'm going to have to go back and find the original article I read because I'm not finding it quickly. And I hate everything because, like, what I was looking at was, this is the planet, that's Alpha and Centauri A and B, and I hate everything. Yeah. Okay.
So why don't we go to like, theoretically larger stars will still have a habitable zone but shorter life.
Okay, that works.
Okay. Do you want to ask the question again?
Yeah, can you ask the question again, please?
Sure.
Sorry.
All right, so we've talked about the smallest stars. And what if we go to the other end of the spectrum? What about stars that are much bigger than the sun? Can they have planets too?
They can. My favorite example of an absolutely not habitable planet is Kelt 9b. This is a very hot Jupiter that is getting its atmosphere removed. Its atmosphere at its surface is hotter than the surface of our sun, and it's getting externally heated by the giant star that it is orbiting. Now, while Kelt 9b is having a really rough time of it, you can move out further and further and further from that star until you find that zone that is cool enough with a long enough orbit that you can actually start to get Earth-like conditions with a very different duration of year.
Right. And I guess it's the exact opposite problem. Like
Yeah.
the planets around red dwarfs have been so easy to find because they zip around, they tug at the star, they block the light from the star on a regular basis. But if you had a planet orbiting around a giant star, now your habitable zone is like the distance to Jupiter. The planet is taking 10 years to go around. It's making almost no impact as it crosses the surface of the star and makes almost no impact in terms of gravity. So these are going to be really tricky to find if they're out there.
They are going to be extremely tricky to find. They fall into the category of things that may be easiest to find through direct imaging as we start to develop coronagraphs. But even then, we're looking at needing massive systems of the kind that it stretches what we're currently building and probably needs to wait a couple more generations of scopes. But the fact that we're finding close-in planets on these kinds of stars tells us all kinds of planets should be possible. And this then gets us to the point of, okay, so we're 5 billion years, 6 billion years into the age of our solar system.
Right.
These stars don't live that long.
Right. You better hurry.
So there is a good chance that you'd hit the point of little tiny microbes going, "Hi, I'm here. I'm a microbe," except they are like single-celled, so they can't think. Yeah, right. And just as they pop into existence, the star pops out of existence, and then what happens?
Right. Okay. All right. Well, we're going to talk about some more weird worlds in a second, but it's time for another break. And we're back. All right. So let's talk about like a double star. Let's talk about a binary star. Can we have a habitable zone around there?
Yes. It's a bit more complicated because there are so many different kinds of orbits in binary systems. So if you have two stars close in together being orbited by planets further out that treat the two stars essentially as one gravitational center, you can have an outer habitable zone. If you have a planet that is orbiting one of two stars in a binary system where the other star is extremely far out and is just like out there being overly bright in your sky but not really producing heat, also okay. You can then get into the complicated geometries of what happens if you are on a highly elliptical orbit trying to handle these two stars simultaneously. It's all going to depend on the geometry of the system. But if you have those magical geometries of, and by magical I mean statistically exactly right, of either the two stars being close together and not with their orbiting each other, varying in brightness enough that it would take you out of the habitable zone, that will work. And if the two stars are separated enough and you're going around only one of them, that can also work.
And so I'm sort of envisioning you've got these two stars that are orbiting around each other, and then, the distance of the Earth away from them, you've got this big habitable zone band, and you could have a planet orbiting in that, going around both of them.
Yes.
And liquid water on its surface.
Yes.
And everything is stable for a very long period of time. Because I guess from that distance, those two stars act as if one. And so if you were on the surface of one of these worlds and you were looking sort of looking at your day, what would it be like?
It would be essentially that Tatooine multiple star system where you see if the stars are far enough apart in the sky to allow you to separate them. You see these two stars that sometimes are super close together, other times might be further apart depending on the orientation of their orbit to you. You'd see them setting and rising together in the sky. And I love this idea that if they're going around each other and you're going around all of them, you basically see over time the two stars passing super close and then further away in the sky. That just would be cool.
Yeah.
Just be cool.
And there was a discovery fairly recent. I don't know if you've been tracking this story, Kepler 16b, which they knew about, but they've been able to piece together that it is going around these two stars, circumbinary. But it's not in the habitable zone, and it's like the size of Saturn. So I don't think a habitable zone planet has been discovered yet. But theoretically, there's no reason to think why. And I guess you could scale that up. I mean, you could have a system with 8 stars and have planets as long as things are stable.
And it gets harder and harder to get stable as you get more and more stars piled in.
Yeah.
But it's still cool.
What about dead stars?
White dwarfs actually have planets in habitable zones, or at least one does, and that's kind of cool.
How's that impossible?
This is one of those things we're still trying to figure out. So we know that planets in solar systems like ours will eventually get consumed, the innermost ones, as the star expands out. We also know that all the objects that are left behind will get disrupted both by the gravity and the ultraviolet light of the youngest stage of life once that white dwarf forms. So you end up with debris disks around white dwarfs, and these debris disks can turn around and apparently form new stars.
New planets.
That's what I meant. Form new planets, or alternatively, it's possible that white dwarfs are just thieves and steal gravitationally planets from other systems. We're still figuring that part out. We just know that we're starting to find examples.
Yeah. Yeah, I mean, they discovered, it's kind of horrific. They discovered a planet orbiting around a white dwarf as it crashed into the white dwarf.
Right. That is not the best way to find a planet, but it's possible.
We found a planet and it's gone.
Yeah.
But I wonder, but I guess the point being, like, that white dwarf will put out radiation because it's essentially the exposed core of the dead star.
Right.
And it's cooling down to the background temperature of the universe.
Slowly.
And it's going to take a long time.
And so worlds that end up around a white dwarf through either a new generation of planet formation or through thievery have the chance to evolve and evolve over time. And we are finding on our own planet Earth that it's a bit easier to deal with problems of your star cooling than your star heating to a point. And so you can imagine having a long time for a civilization to slowly evolve. And the question is, does that happen? What is left behind? And how does it deal with all the early ultraviolet light? That is a concern, but we don't know the limits on life.
Right. And so, we've discounted like the big Jupiters and the Saturns and stuff, but if that planet is orbiting within the habitable zone of its star, it could have moons that are habitable. So,
exactly.
So even if it's a bad planet, wrong kind of planet, it might have the right kinds of moons.
Yes. And that starts to raise the potential of, imagine the icy worlds out orbiting Jupiter and Saturn someday being heated up and becoming ocean worlds. Now, they don't have the gravity to really allow liquid water to be maintained at their surface. There isn't the kinds of magnetospheres you would like. But there are exceptions like Titan. What happens when Titan gets just a little bit warmer? Does it bump it so far out of that triple point, or do we start to get new and interesting physics?
Now I'm gonna, as we just wrap up today's show, I'm gonna blow your mind. There was a really interesting paper written by Avi Loeb and team that a few million years after the Big Bang, the average temperature of the entire universe was room temperature. So,
Fair.
20-ish degrees Celsius, and everywhere, every single
Yeah.
part of the entire universe. And so the entire universe was in the habitable zone.
But we
And
didn't have planets yet.
who knows? Who knows? Obviously, you didn't have a lot of time, didn't have a lot of dirt, but it's such a weird idea to think that you had this,
Room temperature, hydrogen, helium.
room temperature, and some trace other elements
Yes.
everywhere across the entire universe. So who knows what kinds of shenanigans life could have gotten up to in that time period? Who knows? You don't know. We don't know.
Elements.
Yeah, 4 elements. Yeah, okay. I can hear the sarcasm in your voice. Well, I think it's awesome. So.
It is awesome.
All right. Well, thank you, Pamela.
And thank you, Fraser. And thank you. I'm going to make our editors edit here. I don't have the file open. Oh, man. I'm so irritated with the deception I ended up with. Why don't I have any patrons? There are no patrons' names here to read. Apparently I already read. Okay, so let me restart. Thank you, Fraser, and thank you so much, everyone out there. Now, we stuck one extra show in this month, so it turns out we've already read the names for all of our patrons this month. And I just want to say we're so grateful to all of you. Now, if you want to help us end up with more names to spill into more weeks, please consider joining our Patreon at patreon.com/astronomycast.
Yeah, if you want to hear Pamela mangle your name, now is your chance.
It's true. It's true.
Yeah, so join our Patreon. All right. Thank you, everyone, and we'll see you next week.
Thank you. Bye-bye. And then they saved.
Okay. Episode, what did I say it was? 633.
Yeah.
Okay, and I'll start my upload. Okay, so Marina Ripan said, could there be a planetary system with 3 suns? What is the possibility of life on those planets and how those life forms would evolve?
So again, it all comes down to the geometry. Luckily with 3 stars, the most stable way for them to orbit is to have 2 close in and 1 far out. And so ideally what you'd end up with is a planet going around the 2 that are close in and seeing the one that's further out, or going around the one that's further out and seeing the other 2.
Right, right. Like you're not going to get like the whole 3-body problem.
Right.
You're not going to get a stable interaction between 3 stars going around each other. 2 are going to collide, or 1's going to get kicked out. But if you have 2 going around each other, and then a habitable zone around those 2, and then really far away a 3rd one, it would be like Tatooine for your days, but then also it would be like Mega Venus for your nights.
Yeah, yeah.
Right? You would have a and the joke, and so Arjun made the obvious joke when you have a 3-star system is the 3-body problem books, and how it's a terrible, terrible mistake to send a message to any star system with 3 suns. Whatever you do not, like 2 is fine, 4 is okay, but 3 is not to be done. But yeah, Man, I love the three. Like, I'm really excited. Have you heard they're making, like, Netflix is doing a version of the three body problem?
No, I hadn't heard that.
Yeah,
That's
yeah,
cool.
yeah. Oh, it's gonna be so
I
good.
feel
I mean,
like
it's
you
gonna be.
told
I
me
mean,
that and then I forgot and I
it's
feel
gonna be
bad.
so bad. What am I kidding? Here I am. I got trapped. That was bait. It's gonna suck. They're gonna ruin it, and I'm gonna be sad. But if you haven't read the three body problem yet, go read it. It is easily the most mind-blowing series, and not just the first book. You got to
Yeah.
push through the first book and get into the second and the third, but yeah, absolutely a stunning piece of science fiction. Yes, please. All right. Abq Halsey, if you had a super Earth giant star, could the planet become a rogue planet after the star went supernova?
Say that again?
If you had a super Earth orbiting a giant star, could the planet become a rogue planet after the star went supernova? So you've got
Yes.
a
If
super
it
Earth
was
orbiting a
far
giant
enough
star.
out, yes.
Right.
It would have to be far enough out.
But like it would be a bad place to live still. Like once your planet has gone rogue, that means you don't have a star anymore. So now it's going to get cold.
Now you die. Now you
Now
die.
you die. Yeah. Yeah. So I guess you're safe. I mean, I guess you survived.
And I have finally found clarification on the image that sent me down to entirely the wrong place.
Yeah.
I have dyslexia. I've talked about this before. Dyslexia leads to weird things. So the planet is going around B Centauri, and the sentence I misread was B Centauri, a 2-star system. My brain just flopped all of that around to Alpha Centauri B.
Got it. B Centauri. Okay.
Yeah, I hate my brain.
Arjone asks, would life be able to change an ice shell world enough for indications to be findable on the surface?
Not from here. Probably.
Right, but maybe like Europa, like you take a Europa, but maybe make it bigger, maybe make it more, have more energy, more thermodynamic energy. Would it be making any observable impact on the planet? Like crud on the surface?
So we have a couple kilometers thick ice.
Yeah.
And as liquid gets hydraulically forced through, it undergoes chemical reactions, which is why we see cool organic carbon molecules on the surface of these worlds. The question is, would you ever be able to differentiate between normal, just happens because universe organic chemistry and life organic chemistry by the time the liquids have essentially been filtered by several kilometers of ice? It's a collimation tower in reverse.
Yeah, I mean, so like our best shot is to send an orbiter to Europa to fly through, or Enceladus to fly through the geysers and taste them.
Yeah.
With its electric tongue, but I can't even imagine trying to do the same thing. I mean, this is we didn't even talk about ice worlds just because I knew it was going to be sort of a pretty deep rabbit hole. But there are, and we've talked about it in the past, but there are like maybe 1,000 times as many icy objects out there in the universe as there are terrestrial planets orbiting in the sunlight, orbiting in the habitable zone. And yet they will almost be impossible to analyze. So you may know they're out there, but you won't know if there's life there because they're under kilometers of ice.
Yeah.
Which sucks.
Yeah. And it raises the potentials for all sorts of cool science fiction stories, because if you are sentient whales living under several kilometers of ice,
Yeah.
what are the stories you tell?
John Suttle asks, would it be possible for a solar system to have a super Jupiter at the center of a full-on sun
No.
instead of a full-on sun?
Oh, instead of a full-on sun. We call those brown dwarf systems.
So brown dwarf is a super Jupiter.
Yeah.
Yeah.
Yeah. And I don't think we've found any with planets yet. So
No.
I don't know if the solar nebula for those would have enough mass.
Let me see if any brown dwarfs have been found with planets. No.
Yeah.
No. So in theory, like, it feels really likely that you are going to have, based on the fact that planets have been found around red dwarfs and fairly sizable planets. I mean, a brown dwarf is just tiny, a little bit smaller red dwarf.
Right.
It seems feasible. So the question then is how much heat? Like, what would be the habitable zone of a brown dwarf? I'm just looking into
Like
this.
standing on its surface?
Yeah.
I mean, so the issue is they only go through the briefest of tritium and deuterium burning. Not all of them get to the point of deuterium burning. And so they're going to radiate away that heat fairly quickly.
Right. So what I'm seeing is that, yes, theoretically, but it would be really close to its Roche limit.
Okay.
And so it would be really tricky. You'd have just sort of this perfect.
So Roche limit is that point where gravity will break your world apart.
Yep.
So go ahead, finish the rest of your thought.
That's it.
Okay.
That was the punchline. That you need to have like a fairly beefy brown dwarf, and you need to be orbiting within the habitable zone, but not within the Roche limit,
Right.
which would be tricky.
Yeah.
But that's to get the heat on the surface. I mean, if there's other planets around it, they're going to be interacting. You're going to have tidal heating. It's going to be like Europa.
Yeah.
But you really want that on the surface. But even like the other piece of research, we didn't really talk about this as well, is that you really do want that those main sequence photons, that the infrared and the red side of the spectrum photons, they may keep you warm, but they don't give you a lot of energy for sunlight and for doing like plants and things like that.
There's a sweet spot in molecular chemistry where if your light is too blue, it breaks the molecules apart. And if you just don't have enough energy, chemistry can't really happen. So, yeah.
Yeah, so you could be warm. And so this idea, like a planet around a red dwarf could be warm and have liquid water, but it's just not getting enough of the right kinds of irradiance from the star to be able to grow anything. Everything would be very underpowered. Everything would be very sad and slow and, yeah.
Like Greenland sharks.
Lackadaisical. Yeah, exactly. Or like a lichen. Or a plant that's really far under the shade. Those are all the questions that I've got. Here we go. Arjun asks, have we ever done an astronomy cast on the different things Earth has been through, like extinctions? Yeah.
We did one on all the different extinctions.
Yeah. So those are all the questions that I see right now on YouTube. Have you got any questions
on
on Twitch?
Let me look on Twitch. So IOU asks, how much mass does Earth consume via its magnetic field channeling charged particles to our magnetic poles? I don't know that one. Do you?
No. There's a sort of an interesting thing about the fact that the Earth receives dirt every day.
Oh, yeah.
Space,
and
tons. Loses atmosphere every day because of the solar wind. And they're within an order of magnitude of each other.
Right.
But we're, I forget which one it is. This used to be in my head. Gaining or losing this. Hold on, let me get the number. So we're gaining more dirt than we're losing atmosphere.
Okay.
Yeah. But it's actually kind of close. So we're turning more rocky and less atmospheric.
Which will make it easier for us to hold on to future atmosphere, and we just need to outgas more?
Right, yeah.
Something like that.
Yeah, exactly. So the actual number, 100 to 300 metric tons of material every day. And oh, it's really close. So it's about 100,000 tons a year, and we lose about 95,000 tons a year. So the two numbers are actually very close.
Yeah. That's awesome.
Yeah. Anything else there?
Cool. Nope, that was it.
Then we'll just wait. Anyone got a question?
We will answer your questions.
You're ready.
Broken Symmetry is saying we need to outgas more.
Yeah. Yeah, we always need to outgas more. I'm trying to think what else we can talk about then. What did we watch on the weekend?
I am reading the Expanse books because when I initially read them, book 6 wasn't out yet. Mm-hmm. And the series ended very well, but with a few loose ends that I'm hoping I can find out from the books. But I think I brought that up in the last show.
I'm not sure I'm ever going to read them. A couple of my friends have read them, and Carla read them, and the opinion seems to be like they're great, but there was a bunch of issues that were well fixed by the TV show.
Okay.
And so, yeah.
So IOU is asking, what do you think about Elon Musk making Starlink available to the Ukraine? Couldn't neighboring Russia get free internet?
If they have Starlink?
Yeah, you need to have the base stations, and there has to be a relay station.
And it has to be region unlocked for you.
Right. So Musk has unlocked the region that is the Ukraine. They're sending over base stations and I assume a relay station.
Yeah.
So I don't think he's going to unlock Russia.
No, not right now. The one issue that I had heard, and I haven't been able to confirm this, is that the actual dish puts out a fairly strong radio signature that could be visible from orbit, or could be visible by drones, and so you might actually be painting a target on yourself when you're using it to send in and receive to space. But still, I mean, like cutting off telecommunications during a war is absolutely in the book, in the playbook, and so to have these individual little dishes, each of which provides really robust internet service, would be a game changer for this kind of a situation. What is really amazing me is this is the first modern war people have paid attention to in a part of the world where we have ready access to satellite imagery and social media. And it saddens me that we didn't have similar coverage, for instance, of the atrocities that happened in Syria. But we are able to see in satellite imagery the movements of the various forces, and it is affecting how the war progresses. It is allowing guerrilla fighters to work in ways they never have before. It's very different. Maxar has been
that's who I was thinking of.
Yeah, it's an Earth-based Earth observation. I mean, they're a commercial satellite provider, but they've just been dumping pictures of Ukraine out onto social media. that anyone can look at and see columns of tanks and things like that. So it is kind of, space has a big chunk to play. Speaking of space, I don't know if you heard, it looks like the ExoMars mission isn't going to make its launch window this year. So that's the second time that it's been. Last time it lost it because of technical issues. This time, obviously, there's political issues that's stopping it, and so they're probably not going to make this window. So it'll probably be 24.
Okay.
It'll launch, which is too bad.
Yeah. So we're working on putting together a special episode of Daily Space for Friday, where we're going to look at the news that's coming out on how this is affecting ISS operations, how this is affecting spacecraft plans.
Yeah.
The news is very mixed right now, and we're going to do our best.
Yeah, I mean, you're seeing people. Galaxy is saying that I'm quiet. I have no control over this, Galaxy. Don't. It's not me. It's not my sound. I don't control how loud I am. That's all Pamela. But so the European Space Agency's launch facility in French Guiana, the Russians have left there. There's a lot of missions expected to launch on Protons and Soyuz rockets. They're all getting canceled.
Yeah.
Who knows what's going to happen with the International Space Station? There's been some fairly disturbing
harsh
threats made by the head of Russia's aerospace agency about just letting the space
letting
station
it crash into North America.
Yeah, or China or whatever.
Yeah.
Our fault. There was something else that's happening. Anyway, there's a bunch of Russia is one of the most accomplished spacefaring nations on Earth, and has a lot of missions, has a lot of collaborations in the pipe right now, a lot of stuff with China. So I think it's gonna be pretty bad. Oh, the Antares rocket uses Russian engines.
Yeah.
And so I think they've got one more launch, and then that's it for those. And they're going to have to switch over to Blue Origin rockets. I don't know what the plan is. So it's going to be pretty bad.
Yeah. So on a happier note, Elijah Bailey asks, could metaverse technology support the next space missions? And so here you can imagine being able to put on your VR goggles and walk around on the surface of Mars, for instance, in partnership with your rover whose eyes you're looking through. This is something where I actually know some people who've been trying to figure out how to get the funding to develop this technology so that geologists can essentially do field work on Mars by walking up to the cutouts in the terrain that have already been imaged and doing everything short of hitting them with a rock hammer.
Yeah, looking at them really closely, examining. Yeah, it's really interesting. They could just walk around on a simulated Mars, all the pictures that have already been taken, and then study it very carefully and identify places that the rover should drill. And there's nothing like, for a geologist, being out there in the field and looking around and looking up slope and looking down slope and seeing how various minerals and stuff are mixed together. That would be great.
Arctitufus points out the lag with such VR systems would be horrendous. And here it's not a matter of working in real time. You are instead going into already acquired imagery, holodeck style.
Right. But European astronaut was able to, from the space station, control a rover down on the surface of the Earth. I don't know, he wasn't using VR, but it was, it was like a video game. And so one of the big expectations is that and this was to test essentially this version, but on the moon. And so you can imagine there will be astronauts in, say, the Deep Space Gateway, relatively close to the moon, and they are controlling in a virtual environment the rover as it's crawling around on the moon. They're like a drone operator, but they're controlling a rover that is just, a few 1,000 kilometers below them on the surface of the moon.
And
So
that would
I
also
think,
work for Phoebus and Deimos, but to a much
yeah,
lesser degree because they're zipping around so fast.
yeah,
So yeah.
yeah. I think we're going to see a lot of this, a lot of this kind of tele tele telerobotics. Yeah, teleoperated robotics, where people are in the space station, but they're controlling robots outside the station, and a fully immersive 3D environment would be the way to go. So I think we're going to see this technology just grow and grow and grow. It
Yeah.
just has to not suck.
Yeah, the haptics aren't there yet, and
Yeah,
that's where they really need to
and you have to
work on
tie a
improving.
and you have to tie a giant weight to your face and sweat in it,
Yes.
and it makes
Yeah.
you vomit, and there's all kinds of problems. So we're not there yet, but you can absolutely imagine the time when we will be there.
Yeah. Contact
Um,
lenses.
Carolyn B is talking about Nightfall by Isaac Asimov. So a planet in a system with 6 suns.
Oh man.
Yeah, you not read Nightfall? Essentially,
I
the gist of Nightfall is that this planet has 6 suns, and so it's never night. And yet, because of a weird orientation, they're going to have their first night in 1,000 years,
oh
and
jeez.
everybody goes crazy. But yeah, in theory, right? You would have, but again, like, just remember those fundamentals. You can have 2 planets orbiting each other, and then another planet orbiting farther away. So you could have 2 planets orbiting each other, and then 2 more planets orbiting each other, and those 2 are far away and orbiting each other. So now you've got 4, and then you could have 2 more planets orbiting
You
each
mean
other, and they're
stars?
2 more stars. Yeah, 2 stars
Yeah.
orbiting each other, and they're orbiting the 4 stars really far away.
Yeah,
And then you
yeah.
could have 2 more stars orbiting each other, and they're orbiting together, and they're orbiting around the 4 stars that are orbiting around each other in the middle. So as long
Right.
as you stick to that very stable way, it's almost like electron shells. You can go out, and I think the biggest is 8 so far. 7, 8 has been seen.
I've lost track. No
Yeah,
lies.
yeah, yeah. So there's a, a star system out there with 8 stars in it, which is pretty cool. Okay, well, we've reached the end of our hour. So, and I think we've reached the end of our questions. So we're in perfect balance. What are you working on?
Um, well, we're working on that special episode for Friday for Daily Space, which you can watch live during the recording at 2 p.m. Eastern. That is 11 a.m. Pacific on twitch.tv/Daily Space. And then we go out on Now Media. We're never quite sure when our episodes are going to air week-wise, but I'd expect it to probably air Sunday night on Now Media. So we're working on that.
So the new Nyack Awards are out, which is, of course, Christmas for me. So there was like 12 new Phase 1 Nyack announcements, and then 6 went to Phase 2. And so I've reached out to pretty much every researcher who was involved in one of these projects and have invited them to do an interview with me.
And Nyack Awards are?
Oh, the Nyack Awards, they're the NASA Advanced Innovative Concepts, and they
Okay.
are so a lot of like really cool ideas like magnetic bubbles that shield a
Right.
spacecraft, or a manta rays that will fly in the atmosphere of Venus, or the the sun shield, the star shield was originally a Nyack Award, a lunar elevator. And so just every time they're just these great ideas that probably will never happen, but it showed that like NASA is investing in just like really out of the box ideas.
Right.
And it's really fun to talk to the people who are working on these projects. And so, I always had such a good time, and I know the audience really enjoys it. So this time around, I was, you know what? Like, the new list is out. I'm just going to ask everybody.
That's awesome.
Yeah, one of the look here. I'll give you just the quick. Hold on, I just got to give you the list here because they're so cool. Well, so one of the people who said yes is John Mather, Nobel Prize winning.
Wow.
Yeah, John Mather is working on a sun shield for Earth-based telescopes. So an orbital star shield. Silent solid-state propulsion for advanced air. So essentially, ion engines for Earth airplanes. 3D printed spacesuits that for Mars and such.
That's cool.
A better way of producing air on Mars. A defense system for protecting us from asteroids that would work at the last minute, essentially obliterating. Yeah, the hybrid observatory for Earth-like exoplanets. So it would be half Earth telescope, half star shield that would be in orbit around the Earth, and would allow us to see Earth-sized worlds. So there's a ton of really cool ideas. All right, let's wrap it up.
All right.
Thank you, everyone, for watching us today. Really appreciate it. Thanks, Pamela, for bringing the brain. Thanks to all the moderators for keeping the chat friendly. Thanks to everyone who asked us questions and watched us on both YouTube and on Twitch. The next thing that's happening, I guess, is I'm doing my open space tonight at 5. So stay
And then
tuned
we'll
for
be
that.
back with Daily Space tomorrow. So.
Right on. All right.
Okay.
We'll see all of you next week or later on today, tomorrow, or on Wednesday for the Weekly Space Hangout.
It's true.
Yeah.
It's true.
Yeah. All right.
Okay.
We'll talk to you later.
Bye-bye.